All right, this is 9.3 solubility curves. And what a solubility curve is it simply allows you to see how much of our solute we can dissolve per 100 grams of solvent on a graph. And so here, what we see is if you have KNO3, potassium nitrate, as temperature increases, the amount of solute you can dissolve per 100 grams of H2O is increasing, right? And so what we can see is that at different temperatures, right, the points here are telling us exactly how much of what's the maximum amount of solute that you can dissolve. Now, do note that the points are the maximum at that temperature, right? And so, for example, if, let's say, let's just label these 10, 20, 30, 40, at 40 degrees, you know, if you put this much, a amount of solute, this is what we would call, A is an example of saturated. We would have a saturated solution. And that's because we have put more than the maximum amount of solute that can be dissolved at that temperature for that substance, right? And so that is a saturated solution. Versus B is an example of a unsaturated solution. We have put less than the maximum, right? We have put less than the maximum amount. Versus, lastly, C is also a saturated solution because we have put exactly the maximum. And so the definition of saturated is a solution that contains the maximum amount of solute or greater than that, which is capable of being dissolved at that temperature. And so A and C are examples of saturated. Anything below the line is unsaturated. Anything above is saturated. And so that's the basic idea here of solubility curves and how to read them. Now, here in 9.3, what I had you do is I don't know why, but solubility curves generally have a ton of them overlapped on the same graph. And what I did is I had you answer a couple of questions. And so let's do that to help you guys out. I was especially interested, well, let's start off with maybe number 1, and then we can go to 2 for a harder one. Right, but what mass of solute will dissolve in 100 milliliters of water at the following temperatures? Now do note, 100 milliliters of water, this is per 100 grams of water. Remember that grams is equal to milliliters for water. And so here, this is telling you mass of solute per 100 milliliters. And so for KNO3 at 50 degrees, what we can do is we can locate the KNO3 graph, which is this one, and then locate 50 degrees, and we can say, okay, well, at 50, we can dissolve at max 80 grams, right? Because, do you see how that matched up here? Right? And so we have 80 grams of KNO3 that can dissolve per 100 milliliters of water at 50 degrees Celsius. Now let's go on to the second one, NaCl. NaCl is I believe it's this guy. Yeah, it's this guy. So here, if you are at 60 degrees, how much NaCl can we dissolve? Well, that is approximately 38, right? 38, 37. Now, do note, I think in my answer key, I did approximates, and so that's okay, right? Like on a test, if you do 37, I will not take off points, right? Don't freak out. If you do 39, I also won't take off points. Heck, well, you know, honestly, you probably shouldn't do 40 because we're not quite at 40 yet, but like if you do, you're probably still fine, right? Just give me your best estimate, right? So that's okay. So then lastly, NH4Cl. NH4Cl at 100. That is approximately 75. Approximately, that's what that little squiggle means. Approximately 75 grams. Cool. Okay, so that's the practice determining the solubility. Now let's look at these examples where it says a solution that contains 80 grams of NaNO3 at 30 degrees Celsius. So if you have 80 grams of NaNO3, 80 grams of NaNO3, oh, I'm sorry. I went reverse, right? If I have 80 grams of NaNO3 at 30 degrees Celsius, so at 30, 80, is that saturated or unsaturated? Well, note, NaNO3, this is its curve. We're below the curve, so therefore we must be unsaturated, right? If unsaturated, how much more solid can dissolve? Basically, how far are we from the max? Well, here we're at 80. The max is approximately like, maybe like 98, right? So approximately, we could dissolve 18 more grams before we reach the saturation, before we reach the limit, right? And so that's how you would do that problem. Now, if saturated, well, we're not, we're unsaturated, right? So you don't have to do that one. All right, let's go on to number 2. A solution that contains 100 grams of NaNO3 at 30 degrees Celsius. Well, NaNO3 is here, and we have 30 degrees, we have 100 grams. 100 grams at 30 degrees Celsius, and so I guess this is kind of the opposite of our last one, right? So let me put that in blue, right? And so here's our max, right? We are above the line this time, right? You can see we're above the line, and so this time we are actually saturated, right? How much saturated are we? Well, approximately, right? Maybe 2 or 3 grams, right? Something like that. Maybe, honestly, 2, 3, 4, maybe even 5, but right, it's okay to be approximate. That's okay, right? If you said 10, well, no, that's quite clearly not 10, right? If it was 10, it would be this, but right, it's okay to be a little bit off. And so, and I'm sorry, I should have put that here, right? Because we're saturated, and so therefore, how much solute will be left undissolved? That's 2 grams. We're not going to worry about that. And so there are 2 examples. Let's just do one more. 80 grams at 50 degrees Celsius of KNO3. 80 grams at 50 degrees Celsius. Oh, would you look at that? This is actually similar to the one that we did up here, right? We have 80 grams at 50 degrees Celsius. We are exactly on the line, right? And so is that saturated or unsaturated? Remember we said that is saturated. It's exactly the max. And so we're not going to worry about this one. How much solute will be left undissolved? Well, none, right? We're right at the max. And so we don't have to worry about anything being left undissolved, but we can't dissolve any more. And so that's how you do these. The question of what is the solubility of KCl, that's just saying the max, okay? So solubility is the max amount that you can dissolve. And so, for example, KCl, 15 degrees Celsius. KCl at 15. Ooh, that's a little bit hard to see between all of them. Cool, okay, it's this one. All right, it's approximately 30 grams, all right? And so just solubility is asking for like on the line. But yeah, so hopefully that helps. Hopefully that helps you read solubility curves. Let me know if you have any questions.